Alright, so on number 1, it says suppose f has an inverse. If f of 2 equals 6. So that basically means when the x value is 2, the function value, which is like the y value, is 6. So inverse functions, what they do is they switch the f and the y value, or sorry, the x and y value. So that means f inverse of 6 would equal 2. You guys remember when we flipped over the line y equals x, I said you just switch the x and the y values. Like if this one has the point 2, negative 3, the inverse has a point negative 3, 2. So that's basically what's going on here. So on number 1a, f inverse of 6 is 2. B, what's f inverse of f of 3? Well, what's f of 3? 7, says it in directions. So what's f inverse of 7? 3. So they're trying to point out that they cancel each other out. F inverse and f, they kind of reverse each other. So, yeah, that's why they call it an inverse function. So it goes back to 3 again. C, what's f of f inverse of 7? So what's f inverse of 7? 3. And what's f of 3? 7. So they cancel each other out. Number 3. G of 3 is 5. G of negative 1 is 5. Explain why G has no inverse. Okay, so this is just a little sentence answer. So a function has that for each x value there's only one y value. But the inverse would be basically have to have each y value could only have one x value. So on number 3, the inverse function for g would have to mean g inverse of 5 equals 3 and g inverse of 5 equals negative 1, which is not a function. It's like a no-no. So I don't know if you would say it has no inverse, but it has no inverse function. I think is a better way of saying that. What the book put is g is not 1 to 1. So what that means is for every x value there's only one y value, and for every y value there's only one x value. So, but they just put g is not 1 to 1. Number 5, sketch the graphs. So, I don't think we're going to need graph paper for this. These are only 2. And usually when they say sketch, they don't mean like a little rougher than normal. So we'll just do it by hand without the graph paper. All right. Sketch the graphs of h of x. How do we graph h of x equals 4x minus 3? Start where? Start down 3. Where do I go from there? Up 4 over 1. Up 4 over 1. Okay, how do I graph the inverse? Well, we could reflect it over the line y equals x, like we did the other day. Or we could find the inverse function, which we're going to have to do for b anyway. Or probably the easiest way. We can just switch the x and y coordinates. So this is at 0, negative 3. So what's the inverse point for that going to be? -3, 0. Okay, this is at 1, 1. What's the inverse point of 1, 1? 1, 1. So, stays there. This is 2, 5. So, 5, 2. Okay, so B says find a rule for the inverse. Alright, how do we do that? Flip the x and y. So h of x is like the y. So x equals 4y minus 3. How do I solve that for y? Plus 3. Divide by 4, right? You could leave it like that, or you could split it up. It's also 1/4 x divided by 3/4, or plus 3/4. Anyway, that either of those would be the answer. I think the book actually put that one. This one's more useful for graphing, although I don't really need it at this point. But okay, I'll just put the book's version. X plus 3/4. If you want to change that, both of those are divided by 4. It's like the distributive property. You guys remember solving for y. Alright. Let me look at number 6. Kind of same thing. Okay, number 7. In exercises 7 through 10, the graph function is given. Does the graph have an inverse? How can I tell just by looking at the graph whether it has an inverse? Which test? Horizontal. So, is number 7 a function? Yes, because it passes the vertical line test. But is its inverse a function? Does it pass the horizontal line test? Does it, if you draw a horizontal line anywhere, does it hit more than once? Okay, no. It gets really flat at 0, but that's just for an instant. That's like kind of like a triple root thing. But no, there is actually no point. Triple roots only are flat for one point. So actually it only hits at 1 point. Any horizontal line you draw only hits at 1 point. So yes, there is an inverse function for number 7. Okay. Does number 9 pass the horizontal line test? No. Each of those points, like this is the greatest integer function from yesterday. At x equals 0 and 0.1, 0.2, there's a number of points on that line. So if you draw a horizontal line, it's going to hit multiple points. So 9 is no. Okay, on 11. State whether the function has an inverse. If it exists, find a rule for the inverse. Show that f of f inverse of x equals x, and f inverse of f of x equals x. Phew, sounds like a lot. Alright. What would the graph of number 11 look like? Yeah, slope of 3, y or something like that. Would that have an inverse? Would it pass the horizontal line test? Yes. So it does have an inverse. And we're supposed to find it. So I'm going to switch the y and the x value. So I'll call it x equals 3y minus 5. And the function's called f of x, so f inverse. Okay, and then I'll solve this for y. So you could say it's 1/3 x plus 5/3, or just x plus 5 over 3. All right. They wanted us to do it both directions, but I think I'm only going to do it one. So we're supposed to show f of f inverse of x equals f, or sorry, x. Let's see. So f of x is 3x minus 5. Maybe I'll do it down here. So what is f of f inverse of x equal to? So you guys remember how we plugged one function into the other day? So I guess I'm going to plug, if I do this one, I'm going to have to plug this in right there. So it's 3 times x plus 5 over 3 minus 5. Well, do you guys know what happens with this 3 right here? Remember multiplying fractions? Cancel out. So you just get x plus 5 minus 5, which is what? X. So that proves it is an inverse function. And if you go the other direction, it should work also, but that's enough. By the way, if these are not a function, you don't have to try and find the inverse. Like, for example, I don't think this is one of the problems. Oh, not exactly. Y equals x squared, does that have an inverse? No. It does. It kind of has two inverse functions, like if you switched and solved for y, you get this. But together it's not an inverse function, but it does have an inverse, really. It's not a function. All right, anyways. What are we doing? F of x equals 4th root of x. What does the 4th root of x look like? What if I plug in -1? What's the 4th root of -1? Okay, it doesn't exist. Because what number to the 4th power equals a negative? There's not possible. It's kind of like imaginary numbers, right? I don't think this is called I, though. I don't know what it's called when there's a 4th root, so it's second. But it doesn't exist in the real numbers. What if I plug in 0? What do I get? 0. What if I plug in 1? What do I get? Okay. You guys know what 2 to the 4th is? 2, 4, 8, 16. What if I plug in 16? 2. So like way out there, it gets up to 2. So it's just a really flat function. Have we ever, and the domain is x is greater than or equal to 0. Nothing out here works because it's negative. Have we ever graphed cube root of x? Have we ever looked at that? Can I plug a negative into this? Yeah, cube root of -1 is -1. Cube root of 0 is 0. Cube root of -8 is -2. So it looks pretty similar. Well, actually, it would go up faster than that one. It looks pretty similar to the square root, but it also has negatives involved. So, looks like that. Kind of beside the point, but. Alright, does this have an inverse function? Does it pass for a horizontal line test? Yes. So, first answer on 13 is yes. How do we find the inverse function? Switch to x and y. So x equals 4th root of y. How do I get rid of the 4th root? 4th power. So y equals x to the 4th. I don't know if we graphed that one either. You guys have any ideas what that might look like? Whoops. It's called f inverse again. Well, do you guys know what the roots of this function are? What x values make this function 0? 0. It's a 4th root. You guys remember a double root, it bounces, right? A 4th root, just flatter, basically. So if you plug in 0, you get 0. If you plug in 1, you get 1. So it looks pretty similar there, but when it gets close, it just gets really flat. I don't know if I do that very well, but also it goes up really fast. Because if I plug in 2, I get 16 instead of 4, which is what x squared does. So it's just really steep. Anyway, it's kind of like a parabola. All right, so we're supposed to do what is f of f inverse. Now f of x was 4th root of x. This one will be pretty simple. So what is the 4th root of x to the 4th? Not really much way to show this, yeah. These cancel out. You guys remember last year we wrote this and some of the assignments as x to the 4 over 4? Like the exponent over the root. And so that's just x to the 1, or just x. Exponents and roots are opposites, so they kind of cancel each other out. Fifteen says 1 over x squared. Alright, what happens if I plug in 0 for this function? We graphed a few like this last year, but I'm sure you don't remember. Undefined. Okay, there's a vertical asymptote at x equals 0 because you can't have anything at 0. But what if I plug in, let's say 1, I guess. What if I plug in 1, what do I get for x? What if I plug in 2? I get 1 over 2 squared is 1/4. So at 2, it's already down to a 4th. If I plug in 3, it's down to a 9th. Just getting lower. Will it ever reach 0? No. The bigger the number you plug in, it's like plug in 1,000 and get like 1 over, what would that be? 1 over a million. It's a tiny number, but it's still more than 0. What if I plug in like 0.00001 and then you square it and you get 0.000000001? What's 1 divided by a really tiny number? It's it's a gigantic number because it goes into 1 a bunch of times. Like 1 divided by a million would go into 1. This would go into 1 like a million times. So yeah, if you plug in a tiny, tiny number, it gets huge. So if I plugged in something over here, I'd get something up here. So it's a really hard to hit those, right? I'm trying again. That's close enough. You guys get the idea. Okay, what's happening on the negative side? What if I plug in -1? It's +1. 1 over 1 is 1. I get -1, 1. What happens if I plug in -2? I get 1/4, or -3, I get 1/9. So it's a mirror image over here. If the function was 1 over x, the negatives would still be negative, so it would look more like this on the left side. But since the x squared is making everything come out positive, when you put in negative x values, we're getting positive still. All right. Does this have an inverse function? No, that's a fail. It fails a horizontal line test. So, in that case, we don't have to find the inverse function because it just kind of dies right there. So that's it for that. Maybe we should do a worksheet where we graph all kinds of weird stuff. That might be helpful.